Hi, ladies and gentlemen. Note 6.3 are on interpreting sinusoidal functions. And the first question that we have here asks us to determine the coordinates of the point P, x, y, resulting from a rotation of 70 degrees centered at the origin and starting from the point 3, 0. So if you see right here, the point here is 3, 0. It's going to rotate 70 degrees and it's going to end right here. So I want to know what are these coordinates right here. Okay, so if I were to draw a picture of the triangle that's created right here, I would see that so it started at 3, 0, okay, and it's rotating. I would see that this point xy is formed from a 70-degree angle right here, where this piece right here, this length is my x, and this height is the y, and the radius is 3 because it's a circle, so the radius is going to stay 3. Okay, so in order to find x, I'm just going to use SOHCAHTOA, and I know that I have this x right here, which is the adjacent, and then I also have the 3, which is the hypotenuse. So I'm going to say the cosine, because cosine is adjacent over hypotenuse. I'm going to say the cosine of 70 degrees is x, which is the adjacent, over 3. And then if I want to solve for x, I know that x is equal to 3 cosine 70. Okay, now to find out what y is right here, I know that the y is the opposite, and the 3 is still the hypotenuse, so I'm going to use sine. So I'm going to say sine of 70 is equal to y over 3. Okay, now to solve for y, I'm going to multiply both sides by 3, so I get y equals 3 sine of 70. Okay, so I know what x is, I know what y is, so my coordinate is just going to be whatever I get when I plug it in. So I'm going to figure out right here 3 times cosine of 70, so 3 times 70, take the cosine, I end up getting 1.03 approximately. So we're going to say x here approximately is 1.03, and then here the y value, is going to be 3 times the sine of 70, so it's approximately 2.82. So I'm going to say here y is approximately 2.82. Therefore, the coordinate after 70-degree rotation starting at 3, 0, rotated around the origin or centered at the origin, would be 1.03 and then 2.82. So that's the coordinate that I end up getting right here. Okay, but in general, so that's my answer here. In general, we can always say that if the point starts at the radius comma 0, here the radius was 3, here the point was 3, 0, and rotates theta degrees around the origin, the resulting coordinate has to be the radius times the cosine of theta, that's the x value, because it's always going to be right here when I take a look at it. This is always going to be x, this is always going to be y, this is r, this is theta. So I would still do cosine of theta equals x over r. Therefore, x is still going to equal r cosine theta, and y is still going to equal r sine theta. So the coordinate would be r cosine theta, comma r sine theta. Okay? That's important to know. All right, awesome. So the next question that we have here is how to compare and answer questions about sinusoidal functions. So number 2, it says a local farm sets up 2 different windmills. The 2 graphs show the height of the peak for a blade on a windmill in terms of time. Describe the key features for each of the windmills. So we've got windmill 1, which is our black windmill that we have here. Okay, so I'm going to highlight this one right here. So here's windmill 1. And then we also have windmill 2, which is the red one that we have right in front of us, okay? And it might be helpful for you to highlight it because you don't have it color-coded in front of you, so you guys can see the difference between the two that we're looking at, okay? So if I want to find key features, we find the key features just like we've been talking about in the last couple of notes. The first thing that I want to know is what is the equation of my axis? So for windmill number 1, which is the yellow windmill, okay, I want to find the maximum right here. So to find the maximum, I just look at my graph and I see it has a max of 50 and then it has a minimum of 10. So that's going to be important. Max is 50 meters, min is 10 meters. So to find my equation of my axis, I'm just going to add the min and the max together and then divide it by 2. So when I add it all together, I get 60 divided by 2, which is y equals 30. And if you notice right here, if I draw in the line y equals 30, that's exactly halfway between my peak and my trough of my yellow graph, okay? So equation of the axis, y equals 30. Okay, I also want to know the amplitude. And to find the amplitude, I take the min and the max and I subtract them and then divide by 2. So I end up getting 40 divided by 2, which is going to give me 20. So my amplitude is 20 meters. So it takes 20 meters to get to the peak and it takes 20 meters to get to the trough. Okay, and then the last thing I want to do is figure out the period. And the period is just telling me how long it takes to complete a full cycle. So here we have one cycle, it starts at 0 seconds. And then when I go all the way back up here, I complete a cycle at 0.6 seconds right here, okay? Because each block here represents 0.2 of a second. So my period here is 0.6 seconds. All right, now let's do the same thing for our second windmill, which is the pink one right here. Okay, so to find this information right here, the first thing I want to do is find out what the min and the max are. Okay, so for the minimum of my pink one right here, the minimum is 10 still, but this time the max is 60. So we'll say our max is 60. We'll say the min is 10 meters, okay? So to find the axis, I'm going to add it together and divide it by 2, so I end up getting y equals 35. So the equation of my axis is y equals 35, okay? Now I want to find the amplitude, and to find the amplitude, I subtract it and divide by 2 instead. So I end up getting 60 minus 10, which is 50, divided by 2 is 25. So here my amplitude will be 25 meters. Okay, and then the period is how long it takes to complete a full cycle. So right here, it started here, and then it looks like it completed a full cycle at about halfway between 0.4 and 0.6, so it should be 0.5. I'm just going to confirm that it's true. So if I look here, it completes 2 cycles in 1 second, so it has to complete one cycle in half of a second. So here our period is going to be 0.5 seconds. Okay, so those are the key features that we have for our information right here. Okay, now part B says, what information can you infer from these key features? So we found 3 key features for windmill 1 and 3 key features for windmill 2. I would like you to think about this and write down some notes, and we will take this up next time I see you guys in class. All right, have a great day.